Alright, we're doing the spin the cup project, and first you start off by filling up a beaker halfway with water. That right there.
Beakers are different sizes. What's the
250 milliliter beaker. Alright.
And then you get enough vegetable oil or whatever oil you have to cover just the top of the water. Yeah, that's too much. Just good enough.
Okay. As soon as all the bubbles get situated and everything on the top, you take one type of food coloring, put 3 or 4 drops on one side. Alright.
You take another kind of food coloring and put the same amount on the other side.
Alright. Then you carefully grab the beaker at the top and slowly spin it around just a little bit for about 30 seconds and see what happens. Alright, that's been about 30 seconds. And if you look closely at the top, you can see that none of the food coloring actually combined to make a single color. It actually split up into smaller pieces and stayed the same color.
That right there just got it.
And that's what it looks like afterwards. Alright, so this lab we're doing measuring force with rubber bands. And to do that, we got a cup, 4 rubber bands, and then the rubber band wrapped around the bottom of the cup. And see how much force the cup has. We stretch out the rubber band as far as we can without moving it, and it only goes to about 16. So next,
centimeters.
16 centimeters.
Make that clear.
Alright, next we put 5 marbles in the cup and see how much farther we can stretch it out. Alright, and then it goes to about 20 before it moves. So add 5 more, and then stretch it out again, and then it goes to about 21. Alright, and then keep adding 5 more, and stretch to about 22. Alright, and then finally 5 more. Last 5. Stretch it out. Oh, to about 22.
This lab teaches us that force is a result of mass and acceleration. The more mass you have, the more force it takes to move the object. Good. Okay, this project is about Newton's third law and the conservation of momentum. First thing you're going to do is you're going to get one of these here things.
The cradle.
It's called Newton's cradle. And first thing, raise one ball up on one side and let it go. And the energy is transferred from side to side, hitting one of the balls each time, back and forth. Okay, now try the same thing with 2. As you see, same conclusion. 2 balls go, 2 balls come back and forth, back and forth. Okay, now do 3. And it keeps the process with 3 balls with the middle one moving every time. The action-reaction is in this is because energy is lost due to friction and absorption. Okay, now do 4 balls, I suppose. If you can grab them. And as you see, the same result each time. We were going to interview Mr. Isaac Newton to give you some more information about him, but as you can see, he's busy being dead right now. So we'll just give you some information. In 1642, the same year Galileo died, coincidentally, Isaac Newton was born in Wolfshire, Lincolnshire, England on Christmas Day. He was an English physicist and mathematician who was born into a poor farming family. He started his scientific career at Cambridge, where he studied mathematics. But Newton was forced to leave Cambridge when it closed because of the plague, and it was during this period that he made some of his most significant discoveries.
Newton formulated the classical theories of mechanics and optics and invented calculus. Newton died in 1727 and was buried with much pomp and circumstance in Westminster Abbey, despite his well-known reservations about the Anglican faith.